Hello everyone, myself Girish with SolidWorks tutorials. Today I'm here with meshing types and SolidWorks flow simulation. We'll have a look on local mesh, global mesh. Okay, into that we do have the refinements like refining shells, and we have the advanced refinements and the equidistant refinement and global meshing. Okay, we'll have a brief discussion about these all the types of meshes by using different models like walls and the external flow analysis like vehicles as well as the airfoil structures. Let's get into it. So this is the wall. Okay, wall we can say. You can use the local mesh, and here I'm gonna select all the internal faces so that I can refine entire model. So once you are done with that, you can use the refining cells, and if you want to just increase the fluid and solid boundary, you can set it to level 4 to up to level 7 or 8, like that. So advanced refinements, curvature level you can set it to 5, and even the tolerance level you can set it to 4 or 5. We have the up to level 9 refinements. Okay, even you can change the values there, the curvature, depth and the distance. Okay, so this is the region. If you have the region, you can just define the region as well. So we are just considering these surfaces. Yeah, here tolerance criteria, if you want you can just give a proper value. I'll just define it as 0.001. Okay, so these are the advanced refinement with respect to the curvatures. Okay, so once you set this, you can simply run this entire study, not the solution, only the meshing part. So depending upon the system, it's gonna take some time. Okay, so once the mesh is generated, you can just review the same, and you can go ahead with the post processing if you are okay with your meshing criterias. Yeah, now you can directly go to the outputs, and you can just preview the mesh, and here you can just have the basic look of the basic mesh type. So this is the basic mesh. Okay, by default global mesh will be created, right? That one. And now we have added the local mesh. So if you want to have the close observation on it, you can use all the faces, or if you want to just see where exactly you're looking for, you can simply select the manual faces. Okay, I'll select all the faces here, and the section you can select any of the plane. I'll use the front plane. I'll simply click on show preview so that we can have a look. Yep, so this is the preview. So everything is fine here. Refinement level you can change it to curvature based, and also it will showcase only the curvature regions. Yeah, so now I'll simply hide the model so that we can just preview the entire mesh. And go to the feature tab, and then you can hide entire model. And here you could see how the global mesh as well as the local mesh has been updated, and accordingly the mesh distribution. Okay, at the curvature regions it is too fine, and the wherever the flow is not required, it is quite less as per the global mesh we have applied, right? Could say. Yep, so this is how you can just refine it by using the local meshes. This is one method. So this will help us to get the better outputs at the regions where the curvatures are there and the where close observation is needed. At that region you can mesh it. Okay, yeah, so we'll have a look on external flow analysis and how do we refine with respect to the uh, again local mesh. So this is the model. I'm gonna consider the computational domain as like this. Okay, once you clone it, you can directly utilize the mesh types. So I'll go ahead with the local mesh again. So this time I'll select the faces where I need the refinements. Okay, only these faces or these areas are my concerned. Yeah, so once you select all the faces, you can use the equidistant refinement as well as the channel refinement if needed. Okay, for this I'll use the cell refinement to up to level 3, and the channels I don't want, I'll use the equidistant. So here you can set the maximum equidistant level up to 9, so I'll set it to 4, and you can use the levels. Okay, how many layers you need, so I can select maximum number of layers are 3 here. I'll select the maximum. Here you need to define the values. Okay, let's say the outermost region, so up to where you want it, and then again the middle layer and the layer which is closer to the curvature of the model. Okay, like then you can refine it. So even you can even utilize the advanced refinement at the curvature regions. So just to get the better understanding, I'll just increase the values here. So again, once you are done with this, like if you know the dimensions properly, you can able to set these values. If you don't know, you can approximately set once, and once you preview the mesh, you can just remesh the same to get the better mesh distribution. Yeah, so only equidistant mesh I'm gonna use, and with respect to 3 layers. Okay, I'll simply mesh it. So this is for external flow analysis by using the local meshing, how we need to refine it. Yeah, so here you can simply preview it by using the mesh plot from the output results, and here I'll only define the plane. Then I'll simply use the show option to just see the same. Okay, you could see with respect to regions it has meshed, but this is not exactly completely refined, as we have used the values, very coarse values. So you can even set it to very fine values. Instead of 5 mm, you can go ahead with the 0.5 mm, and you can even just plot this particular mesh plot to exactly center, so that you can observe how exactly the mesh is distributed at that location simply by just edit it. And you can use the values here, or else you can use the actor to drag it wherever you are looking for. Okay, I need it exactly at the center. Simply drag it, and here you could see this is how it is distributed. And at the curvature region, you could see it is still refined comparatively with respect to the medium middle region, second layer. The first layer is very refined one. Okay, now I'll consider this airfoil structure. Okay, I'll use the again the local mesh on it. So the faces, you can select the curved faces, this one and the bottom face, and here you can use the equidistance refinement. If you want, you can just use the refining cells according to the boundaries. Okay, and I don't want these channels and all, I'll just define it later. I'll set the maximum equivalent level to level 4, and I'll use the level 2. Only 2 layers I'll consider, and you can define the values. So it's 50 mm and 5 mm. Okay, consideration. Yeah, so channel refinement, I don't want this, so the advanced refinement also I don't need it. Only the equidistant refinement I have considered, and the cell refinements. Okay, I'll just simply run this, and you'll get the results now. So if you have this kind of external flow analysis needed, you can use this equidistant refinement to deal with the same. I'll use the front plane to just define the same, and you could see this is the mesh refinement with respect to the equidistant refinement. Okay, well, so like this you could able to mesh the models in SolidWorks flow simulation by using the advanced mesh types. Okay, yep, that's all. Seen different types of meshings, that is global mesh and the local meshing by using the equidistance mesh, and the even curvature refinements as well. Okay, for internal flow analysis as well as the external flow analysis, how we can just manually refine the mesh as per the requirement. Yep, thank you all. Please do like, subscribe and share our channel.